So welcome to the second session of hypothesis testing. Today we'll be going through some of the hypothesis tests which we typically do to help us evaluate insights from data. So the first test which we're going to cover today is called as the t-test. T-test is a type of inferential statistic used to determine if there is a significant difference between the means of two groups. So basically t-test can be used to compare means between two samples or two groups, right? So there are three kinds of such t-tests which are available. One is called as the one sample t-test. If you are dealing with one sample, it's called as one sample t-test. If you are dealing with two samples, we call it as two sample t-test. If we are there are two under two sample, there are two kinds. One is the independent one is the paired one. So if if both the samples are not dependent on one another, then it is called as independent test. Whereas if the two samples are dependent on one another, it is called as the paired test. So one more important point which is there is that in t-test, the test statistics follows a student's t-distribution under the null hypothesis. So I told you, right, that when we in the previous video, when we were trying to locate the x critical value and the p value, right, alpha value, sorry, and we had a curve, and I told you whatever test we do, we assume that that particular set of data points belongs to a theoretical distribution. So in t-test, we assume that the data points belong to a student distribution and the test statistics is calculated from the sample. So we assume that it follows from the student distribution, and the null hypothesis, if the null hypothesis is accepted, it means that it follows that distribution. Okay, so we'll do some examples and all our doubts will be clarified. Remember we talked about the calculation of the critical value from a table based on the degree of freedom and alpha, or a level of significance. In the previous video we talked about the calculation of critical value of x, right, which is nothing but calculated from degree of freedom and assume alpha value from a table. So this is called as the t-test table. So here different degree of freedoms, level of confidences, right? So for suppose we have a one tail test, I'll tell you what one tail test is. We'll go to that. Suppose we are looking for alpha is equal to 5%, we're considering 5% error, or level of significance we have assumed to be 5%. So 5% will be where? It will be around 0.05. So if it's one tail and 5% level of significance, and if my degree of freedom is say 10, then my value will be 1.812. This is my t critical value or x critical value, whatever you call it. Since the t test, we can denote it using t critical value, tc. And this is the distribution, guys. Right? If you compare it with the z normal distribution, both of them in almost the same bell curve. It's just that whenever your n is close to 30, right, correct, it approaches 30 data points, it tends to be like a normal distribution. When n is less than 30, it becomes much more flatter, right? So as the number of data points increases, it tends to approach the standard normal distribution. Okay, but it's fine, we do not assume any kind of distributions to follow when it comes to dealing real world data, but no worries, we'll try to see how to do the t-test. Okay, we'll take some suitable examples and we'll learn how to do t-test. Example of t-test: say a study was done to see the presence of dogs as pets on kids. Two groups of teenagers, one group with teenagers who owned a dog for minimum 5 years, and another group of kids who never owned the dog, were presented a questionnaire and the scores were computed. High score corresponds to high cheerfulness and low score corresponds to low cheerfulness. Do dogs have a significant effect on the cheerfulness of kids? Now, whenever you look at this question, what does it trying to say is that suppose you have a bunch of students and you give them some questionnaire so that they can rate some score, happiness score, whatever it is. There was one set of people, one set of students who had dogs. There is one set of people who do not have dogs, and both of these samples of people will basically give you some data points based on scores of cheerfulness. Now I have to check whether the presence of dogs has any effect on the kids. So it's either negative or a positive effect. It may be happier, people with dogs may be happier or sadder, it doesn't matter, but it has to be different from the people who do, or the students who do not have dogs. So what you're trying to calculate, you will try to compare the two samples. So basically this t-test has two samples, right? And that two will be comparing the mean of sample 1, mean of sample 2. We'll use some formula of t-test. Remember, we calculate the x critical with a function of m, s, and df, right? That is what you're going to do now. Okay, let's proceed. So these are my cheerfulness data points of dog, and the cheerfulness data, whatever data point score, right, of no dogs, with sample with people with who do not have dogs. Now these are the questions which typically are asked in hypothesis testing. What are null hypotheses? The first thing which comes to your mind should be, how do I state the null and the alternative hypothesis? So the null hypothesis will be what? Right? What it will be? The null hypothesis will be that the score of people with dogs is equal to the score of people with no dogs, right? Which means that pets do not have any effect on the cheerfulness of kids. That will be my null hypothesis. The more complex one, the more complex scenario will be always form the part of the alternative hypothesis. The more complex scenario generally typically lies in the alternative hypothesis. And alternative hypothesis will say that the mean of these scores of people with dogs is not equal to, because they're asking, do dogs have a significant effect on the cheerfulness of kids? They are not specifying whether it's negative or positive. If they would have said positive, then my m of d will be greater than m of nd. What is being asked? Any effect. So it will be not, it can be less than that or it can be greater than that. That is my null hypothesis and alternate hypothesis. Okay, all right, say this is my null hypothesis. Okay, is it a right tail test or a left tail test? What will you say? It's a two tail test. Why? Because we are using not equal to. Whenever we say not equal to, it means that my md can be greater than mnd or it can be less than. So it's either this tail or that tail. So it's both tail, two tail test. Okay. Next, what do we have? Is it a one sample or two sample test? Of course, a two sample test, because we have people with students with dogs, students with no dogs. Is it a mean test of mean, proportional variance? Here in this case, we'll use a test of mean, right? We'll use a test of which statistical test do you think is appropriate? So here, if you remember, right? If you so here, let me give you some facts. Let me give you some concepts. Whenever we do not have the population standard deviation, right? If we do not, whenever we do not have the population standard deviation, we typically use a t-test. In this scenario, if you look at the question, go back to the question, the population standard deviation is given. The sample standard deviation we can easily calculate from both the samples, but the population standard deviation is not given. So in this case, we'll use t-test. When the population standard deviation is given to you, that is when you will use z-test. Z-test. Both of these tests are very similar. Formula will change, of course. Uh, it again is a function of sample data points, and just like t-test, it has its own corresponding z table where you can calculate the z critical value. The process is exactly same. Okay, right? So which test will be appropriate? It will be the t-test. Since population standard deviation is not given, we use t-test. We use z-test when population standard deviation is given. So let us look at how we calculate all these values. Okay, the step one. Step one is that we'll first assume the level of significance, which is alpha is equal to 0.05, and degree of freedom, which is 16. Degree of freedom here will be n1 plus n2 minus 2. That is how the degree of freedom will be calculated. Again, guys, you don't remember all these formulas. We can calculate the p-value and the test statistic with one single line of code in t-test, which we have in Python. I'll show it to you at the end of the video. So degree of freedom in case of two sample test is always n1 plus n2 minus 2. In one sample test, it will be n minus 1. Okay. All right. Next, what do we have? with alpha is equal to 0.05, this is typically what we assume in the corporate. Okay, always assume typically 5%. Degree of freedom is calculated from the sample. And if you look at the t-test table, right, the two-tail test, of course, my critical value will be plus minus 2.10. Why plus minus? Because it's a two-tail test. It can be negative side, it can be on the positive side. I'll show you in the diagram properly. Okay. Alpha degree of freedoms. Step 2, I'll calculate all these parameters. Sample mean, sample standard deviation for both children with dogs and children with no dogs. From here, I'll calculate the test statistic using this formula. Again, this formula is for t test. Similarly, we'll have another formula for z test. We have another formula for chi-square test, right? But for now, let us not go into the details of the formula. We'll be using, anyways, we'll be using Python functions. But just to help you understand, it is just calculating the difference between the means divided by the, uh, you know, the average of the variance. So if you look at this is average of variance, and taking both of the samples into consideration, and this value comes out to be 0.35, right? Okay, so now since we have t critical and ts, now we can come to a conclusion, right? Okay, so ts is less than tc. So in step 3, finally we can compare ts and tc. So ts, the test statistic, is less than tc, and in this condition what happens? It's not as accepted. So basically means that pets do not have any effect on the cheerfulness of kids, because it seems to me that whether you have pets or not, the average score of cheerfulness or whatever it is, emotion, is the same for both people with pets and people with no pets. So hence we could not prove that pets either increase or decrease the cheerfulness of kids. So here, what would be the error involved then? What is the error involved when H naught is accepted? It is the type 2 error. Do not forget that, guys. So whatever alpha you have considered, this actually is type 2 error. Okay, guys. Now we understood what the steps are, right, and what we have calculated. We also try to visualize this, because when you visualize it, it becomes much more clearer. But before we do that, let's just try to see how we calculate the t critical value. Okay, I just want to show you from the t table how we read the t table and get the values out. So if you look at this, calculate TC from the table, right? So how we calculate it? Alpha was 0.05 and it was a two-tailed test, and degree of freedom was 16, correct? So my degree of freedom is here, and alpha was 0.05. So 0.05, that too for a two-tailed test. You can see here, this is two-tailed test and this is my alpha. Okay, all right. So be very careful, guys. If it is one-tailed, it will be different column which you have to look into, right? Why? Because when we have a distribution like this, okay, when it's a two-tailed test, what happens is the alpha which you actually consider 0.05 gets divided into two equal regions. So alpha by 2 will be put here, alpha by 2 will be put here. So if you want to compare one single value, right, so we either do comparison either side. So if I get a, so this is 0, right, the midpoint is 0. If I get a positive value of t statistic, then I'll compare with the positive value of t critical, right? If I get a negative value of t statistic, I'll compare with the negative value of tc, which will be again here symmetrically located. So, but when you compare, when you try to find the t critical, it will be with respect to alpha by 2 actually. So that's why two tail जो 0.05 के लिए है, वो 1 के लिए क्या बन जाएगा 0.025. So you don't have to get confused. The distribution is pretty similar, pretty straightforward. If you are looking at two-tailed test, the alpha which you consider has to be divided by 2 for a one-tailed test. But here it's beautifully given, two-tail 0.05. But for one-tail it becomes 0.025. Okay, all right. So degree of freedom 16. So probably it will be this. So it will be plus minus 2.120 again, because we're considering both sides. Based on what value of TS we'll get, we'll try to compare with that particular side of the graph. So here degree of freedom is 16. So we'll get the value as 2.120. It will be plus minus 2.120. Okay, cool. All right. So next, let's try to visualize this. It'll be very interesting. What we have in our hands, we have TC plus minus 2.120, alpha is 0.05, right? So if you want to visualize this, this is what is happening. So alpha by 2 will be on each side of the graph because it's a two-tailed test. So 0.025, 0.025. If you go back to the previous slide, we actually have calculated the T critical for 0.025, one tail. See, okay, so don't get confused. For two tail it is 0.05, but for one tail it is 0.025, because when we compare ultimately with T critical, I have to compare it only on one side, right? Either this or this, correct? So alpha by 2 के साथ ही comparison होगा. So minus 2.120 for this side, plus 2.120 for this side. So now if we look at the TS calculation, right? So now if we look at the TS calculation, TS is 0.35, which is less than 2.120, much less than 2.10, but greater than 0. So I'll compare on the right hand part, the positive part, right? Okay, so this becomes my p value, and if you see, it's actually in the acceptance region because my p value is actually much greater than my alpha value. Okay? That's why null hypothesis is clear. So I don't care about the negative region now. I'll compare it with the positive region. But comparing, alpha value was 0.025, not 0.5, not 0.05. Okay. Now, I was just telling you that we can calculate the p value and the t critical value in Python, right? Very easily. So let's look at the Pythonic way of how we do hypothesis testing. I'll show you the application part with taking a proper data set and everything, but let's look into it once during the theory session. It takes one single line of code in Python to calculate p value and t statistic. We can compare p value with alpha, so that we can compare p value with the alpha. So stat.tstat underscore independent. So this is typically the function which we use to compare two different samples. For in our case, which we had people with dogs and people with no dogs, those were two samples, right? Just two sample tests, and that too they were independent of each other, right? So we'll use stats.test underscore independent. We also have t-test for one sample also. It's called as t-test underscore one sample. T-test underscore one sample, right? Similarly, we have t-test for two groups which are dependent, which is called as t-test underscore relative. Those functions are also there. But since the example we're talking about was a two sample test that which were independent, I have shown you only one function. The same question which it took me like 4-5 lines of steps can be done in one single step. So this function gives me two values, the p value and the test statistics. But by default, all these hypothesis test functions give you the p value for two-tail tests, for two-tail. Okay, so if you are doing a one-tail test, you have to divide the p value by 2. So please, you have to be a bit careful. Okay, same thing. The theory part, I told you that you have to divide by alpha. Here, divide by p value if it is a one-tail test, right? So reverse, same thing. So to calculate the p value for two-tail test, this is the function. It takes again one single line of code in Python to calculate t critical. T critical also we can find out. We can then compare t critical with t statistic. So either way, either you calculate p value directly and compare p value with alpha, or you calculate t critical so that you can compare with t critical and t statistic, right? But t statistics though has to come from this function only. So why to do it again, right? We can use this process much more easier. एक ही साथ में p value will also come, t statistic will also come. Alpha to is assumed. You can easily compare. Right? For this process to compare t critical with t statistic, so we have to find out using this function. Again, t critical a separate function. Up to you, but you'll get the same answer. I'll show it to you in the application. So stats.norm.ppf. Okay, ppf is the probability function, and 1 minus alpha, location equals 0, scale is equal to 1. This is the default parameter which you have to put. For one tail test, it is alpha. For two tail test, it will become alpha by 2. Okay, we have to remember these things to calculate. This is what we looked into. So this is what we have for t-test in Python. and we'll do multiple case studies so that we can evaluate every type of t-test which is available. One sample, the two sample independent and two sample dependent, right? All of them. And we'll see what are different ways of doing the hypothesis test. We can compare p-value with alpha. We'll compare t-statistic with t-critical. If I use this formula, will I get the same result after comparison? We'll look into all those things and it will be same. When to divide alpha by 2, when to divide p by 2, we'll also check it when we do the case study. So right now, it might be a bit difficult to relate to this, but once we get to the code and do hands-on, you'll automatically understand. Hypothesis testing statistics is best understood with the help of examples, not through just theoretical explanations. Okay, but even if you have not, fully explained the last slides, fine, because we'll go to Python again, redo the entire process. But the theoretical part, I believe, is clear. Okay, all right. What is one tail, two tail here? We will explain what is two tail, both sides, but ultimately when we calculate the TS statistic, which is positive here by 0.35 is positive. So I will obviously compare on this part. When I compare, I have to make sure that my alpha is divided. So this value which I'll get is not for alpha equal to 0.05, but this will be for alpha is equal to 0.025 half. So this value itself is calculated because alpha has been divided in both the regions. Total मिलने के कितना है 5%. But if it would have been a one-tailed test, if my alternate hypothesis would have been not this, but this, something like this or less than whatever it is, at that point, right, it would have been a one-tailed test. And if it is one-tailed test, this region will not be there. The entire 5% will come here. And this value will not be 2.120. क्या होगा? Area will slightly increase, right? Area will slightly increase. My T critical value will be slightly lesser. Let's check. Let's check from the table. See, now for alpha, this one we had 2.120, right? But if it would have been a one-tail test, this is 0.05 one-tail test. The entire 5% on one side. Look at the T critical value. Didn't it reduce to 1.746? Right? Because the entire alpha is concentrated on one side, 5% instead of twice the size, right? So my T critical will reduce. So once the T critical reduces, what will happen? My area of rejection will increase, right? So it was here for alpha 0.05 for alpha. This was T critical was here for 0.025. For 0.05 is almost this much. So this is actually 1.76, whatever it was there, right? So rejection region, the probable chance of the TS crossing the TC increases, more prone to rejection. That is what it means. Okay, so we'll continue this lectures. We'll continue with this explanations again in the next video, guys. Okay, so please be patient, and we'll also implement all of this in Python. Become literally much more easier to understand. I hope you enjoyed today's session. I hope you guys are learning, and these videos are adding value to your knowledge. And stay tuned, keep practicing, reach out to us for any problems, and see you in the next video.